Dear students, last class we were solving properties of definite integrals. In that, three properties already got over: P0, P1 and P2. Now, P3 property we are going to solve. Property P3 says integration of f of x with respect to x from a to b is equal to integration of f of a plus b minus x into dx from a to b, where a is lower limit of the integral, b is upper limit of the integral. They have taken sum of upper limit and lower limit c. Okay, how to prove this? Let us take RHS here. RHS is equal to integration of f of a plus b minus x into dx from a to b. You see, in place of this a plus b minus x, we need x there. So, what you substitute? You substitute t is equal to, we need x but you are taking t. With the P0 property we can change it, yes. So, t is equal to a plus b minus x. Then differentiating the function with respect to x, we have dt by dx is equal to a, b constant values minus as it is, differentiation of x is 1. We have minus dt is equal to dx here. Then what happens to the upper limit and lower limit? When x is equal to a, t is equal to a plus b minus a. Plus a minus a get cancelled, this is b. Next, when x is equal to b, that is upper limit, t is equal to a plus b minus b. Plus b minus b get cancelled, a. Okay. Now, we have our RHS as integral of, I am substituting here f of, in place of a plus b minus x, I am taking t. Next, what is dx? Dx is minus dt, minus I will write outside into dt. Then what about the upper limit and lower limit? Lower limit x was a, now it is t, b. In the same way here t is a. Almost we got the answer here with this substitution, t is equal to a plus b minus x. See, using the property, that is property P1, what it said? A to b f of x into dx is equal to, if you interchange upper limit and lower limit, what happens? Integral multiplied with the minus sign. B to a f of x into dx. In the same way, in our RHS, what I do? I will interchange upper limit and lower limit, because I want it from a to b. Interchanging upper limit and lower limit, this become a to b multiplied with minus means minus become plus. A to b f of t into dt. Next, t is there. What do you want? X you want. So, use property P0. What it is? A to b f of x into dx. Because integration of f of x with respect to x from a to b is equal to integration of f of t with respect to t from a to b. This is the property we have. With this, we have proved this is nothing but LHS. So, we have proved the property here. Integration of f of x from a to b with respect to x is equal to integration of a plus b minus x into dx from a to b. This is about property P3. Property P3 can be asked for 6 mark. Here directly they will not give this for 6 mark, they will split the mark as 3 plus 3. For this property derivation 3 mark and a single problem on that property, using that property only they will give you the problem 3 mark. Total 3 plus 3 is equal to 6 mark, like that they may give. Now, coming to the property P4. Property P4 is particular case of property P3, but it is named as another one property. So, integration of f of x with respect to x from 0 to a, integration of f of x with respect to x from 0 to a is integration of f of a minus x with respect to x from 0 to a, 0 to a, 0 to a, here also a to b, that is fixed. A plus b minus x, here it is a minus x. In place of the lower limit 0 is there. It is same as property P3 only, but it is named as property P4. Let us do it. Property P4. Anyhow it is a particular case. Okay. To prove property P4, same way what I do, I will take RHS here. RHS is integral of f of a minus x with respect to x from 0 to a. Okay. Now, in place of a minus x, what we want? In place of a minus x, we want x here. So, you don't take like x is equal to a minus x, that is wrong. You should take another one variable only. T is equal to a minus x I am taking here. Yes, taking t is equal to a minus x and differentiating the function with respect to x. Differentiating the function with respect to x, we have dt by dx is equal to differentiation of a is a constant part, that is 0 minus 1. I have minus dt is equal to dx. This is minus dt is equal to dx. And what happens to the upper limit and lower limits here for the new variable t? That is, when x is equal to 0, lower limit x is equal to 0, t is equal to a minus 0, that is a now. Next, upper limit, when x is equal to a, upper limit a, what happens to the t value? T value is a minus a, with this substitution a minus a is a 0. Okay. Now, our RHS will be integration of f of, in place of a minus x, what I am substituting? I am substituting t, f of t, and to dx is there. What is dx? Dx is minus dt. Minus I will write outside into dt. Next, lower limits and upper limits. When x was 0, t is a, write a here, and when x is a, t is 0. Here is 0. Okay, almost we got the answer. If I interchange upper limit and lower limit, what happens? Value of the whole integral will get multiplied with the minus becomes plus. This is 0 to a f of t into dt, because property integrating from a to b f of x into dx is equal to minus of integrating from b to a f of x into dx. Using that property I am writing like this. Next, in LHS x is there. How to get that x? Yes, using the property P naught. 0 to a f of x into dx I am writing, because it is integrating from a to b f of x into dx is equal to integrating from a to b f of t into dt. That is the property P naught we have. Yes. Same way, property P naught, P4 if it is given, they will give you like they will give for 6 mark 3 plus 3 division, 3 for the proof of this and 3 for the problem. This is about property P4. Now we will move on to the next property, that is P5. P5 property, integration of f of x with respect to x from 0 to 2a is equal to, integration of f of x with respect to x from 0 to 2a is equal to integration of f of x with respect to x from 0 to a plus integration of f of 2a minus x, f of 2a minus x from 0 to a into dx. This is what the property given here. What is that? Integration of f of x with respect to x from 0 to 2a is equal to integration of f of x from 0 to a half of 2a, and plus integration of f of 2a minus x. 2a is the upper limit, f of 2a minus x from 0 to a it is again. Now this is property number P5. Okay, how will you prove this? Here let me take LHS only, that is LHS is equal to integration of f of x with respect to x from 0 to 2a. See, from 0 to 2a we are integrating. Instead of integrating from 0 to 2a, I will split it like 0 to a and a to 2a using a property. That property is property P2. Using the property we can write like that, means 0 to a. And why are you taking only 0 to a? You can think like RHS you see 0 to a, 0 to a is there. So that's why you split it like 0 to a. 0 to a f of x into dx plus of. Next, what happens here? 0 to a I am integrating, then now I have to go with the a to 2a. A to 2a f of x into dx. Let me name this as equation 1 here. This is what? This is because integrating from a to b f of x into dx is equal to integrating from a to c f of x into dx plus integrating from c to b f of x into dx. I am using this property here, so I have written like that. Next, in place of in RHS you see we need this integral from 0 to a f of x into dx we need. Okay, it is there, we no need to worry. Only thing is that we need to do some changes in this second integral. So let me name this as I2. Let me name this as I2, and I2 is equal to integration of f of x with respect to x from a to 2a. It is a to 2a. Here I will modify something. How will you modify? See, RHS you see in place of this x we need 2a minus x over there. So what to substitute? You substitute t is equal to 2a minus x. You substitute t is equal to 2a minus x substitution. This implies x is equal to 2a minus t also. You can take x is equal to 2a minus t also, no problem. Okay, I am taking t is equal to 2a minus x. With this substitution x is equal to 2a minus t, we have differentiate this function with respect to x. This is dt by dx is equal to differentiation of 2a is 0 minus differentiation of x is 1. Okay, it is nothing but minus 1. Then what is dt equal to? Dt is equal to minus dx. This is minus dt is equal to dx. Minus dt is equal to dx. What happens to the upper limit and lower limit? When x is equal to a, that is lower limit, t is equal to, with this substitution it is 2a minus a, we are getting a only. Next, when x is equal to 2a, that is upper limit, what happens to the t? T is equal to 2a minus 2a, 2a minus 2a is 0 we are getting. So I2 is equal to integral of f of x. In place of x what will come? 2a minus t will come. Dx is minus dt, minus I will write outside into dt, and when lower limit x was a, it is a only, you write this a, and upper limit x, for x upper limit was 2a, it is 0, so you write 0 here. Next, almost we got this I2. I want 0 to a, so what to do? Use the property. We are interchanging upper limit and lower limit. A to 0 it is there. 0 to a, what happens? Multiplied with minus, minus minus becomes plus. F of 2a minus t into dt. Why this is? This is because integrating from a to b f of x into dx is equal to minus of integrating from b to a f of x into dx. This is the property we know. And next, integrating from 0 to a, in place of t we want x. Yes, directly you change this f of 2a minus x into dx, because integration of f of x with respect to x from a to b is equal to integration of f of t into dt from a to b. Okay, now this is I2. I will substitute this I2 in the equation 1. I2 was a to 2a f of x into dx. With that substitution t is equal to 2a minus x, we got I2 as 0 to a f of 2a minus x. Therefore, equation 1 implies LHS is equal to 0 to a f of x into dx plus I2, I got it as 0 to a f of 2a minus x into dx. This is what? This is RHS. Hence, we have proved the property integration of f of x with respect to x from 0 to a is integration of f of x with respect to x from 0 to a plus integration of f of 2a minus x from 0 to a with respect to x. This is about a property P5. Now, we left with two more properties, that is property P6 and property P7. Property P6 and property P7 both are important ones because many times these properties they have asked, and if P6 and P7 appear in the exam, marks distribution will be like 5 plus 1. 5 will be for the derivation of the property and 1 will be a problem on that. Okay. What property P6 says here? Property P6 says integration of f of x with respect to x from 0 to 2a is equal to integration of f of x with respect to x from 0 to 2a is equal to, it will take two cases. One case is that it is 2 times 0 to a, 2 times integration of f of x with respect to x from 0 to a when f of 2a minus x is equal to, when f of 2a minus x is equal to plus f of x. This is 0 when f of 2a minus x is equal to minus f of x. See, P6 property it is saying integrating from 0 to 2a f of x into dx is equal to two cases. First case is that it will be 2 times 0 to a f of x into dx when f of 2a minus x is plus f of x. It is 0 when f of 2a minus x is minus f of x. Okay, let me prove this. To prove this property P6, I will take this part 0 to 2a f of x into dx. 0 to 2a f of x into dx I am taking. Then see, in this RHS 0 to a is there. So, instead of integrating from 0 to 2a, first I will integrate from 0 to a, then second integral I will take from a to 2a. So, here it is 0 to a f of x into dx plus of a to 2a f of x into dx I will write. Let me name this as equation 1. In this equation we are going to modify. How I am writing this? I am writing this because integrating from a to b f of x into dx is equal to, we know this, integrating from a to c f of x into dx plus integrating from c to b f of x into dx. We know this property. Using this property I am writing here. I don't have enough space here, that's why I will erase this. You need to write it. Now, here 0 to a let it be, I want 0 to a, then I will modify this. Let me take this as I am taking this as I, that second integral I am taking. I is equal to a to 2a f of x into dx I will take. That same thing I have taken here. Now I will modify here. I will substitute something here. How to take that? T is equal to, how to substitute? See, two cases are there. When f of 2a minus x is equal to plus f of x, when f of 2a minus x is equal to minus f of x. Means what I want in this function, I want 2a minus x, so that I can go with both the cases. When first case, when second case, that is like that we can prove. So here what I want, you know, I want f of 2a minus x. Hence I will substitute t is equal to 2a minus x. Let us put t is equal to 2a minus x. What happens with this? Differentiating the function with respect to x, we have dt by dx is equal to differentiation of 2a is 0, differentiation of minus x is minus 1. This is minus dt is equal to dx. Okay. Then what happens to the upper limit and lower limit here? When x is equal to a, lower limit, when x is equal to a, t is equal to 2a minus a, x is equal to a, I am substituting, 2a minus a is a. Next, when x is equal to 2a, when x is equal to 2a, t is equal to 2a minus 2a, 2a minus 2a is 0. Okay. Now I is equal to, integral I is equal to integration of f of, in place of x, what I substitute? T is equal to 2a minus x I am taking. So here x is equal to, this will be 2a minus t. Okay. Substitute, in place of x you substitute 2a minus t. dx is nothing but minus dt. dt you write here and minus you write outside. And lower limit, x was a, now t is also a. x at 2a, t become 0. So upper limit is 0. Next, here a minus is there. If I interchange upper limit and lower limit, this become 0 to a f of 2a minus t into dt. Why this is? This is because integrating from a to b f of x into dx is equal to minus of integrating from b to a f of x into dx. Okay. Then I don't want this t. I can change the variable to another one variable, that is x. 0 to a f of 2a minus x into dx, because integrating from a to b f of x into dx is equal to integrating from a to b f of t into dt. As you will be proving, this is for the 5 mark. All this reason why we are doing this, it is must and should you write it. I is equal to, see the integral I, a to 2a integration f of x into dx become 0 to a f of 2a minus x into dx. Now equation 1 implies 0 to 2a f of x into dx is equal to 0 to a f of x into dx. First one, that is as it is. Second integral, we did some substitution and we are changing it, that become 0 to a, this one, f of 2a minus x into dx. This is same as per the property P5. Up to this we need to write. Now we will go with the cases here. Here this is LHS and this is RHS. RHS two cases are there. One case is when f of 2a minus x is equal to plus f of x, we should get this one. When f of 2a minus x is equal to minus f of x, we should get 0. Both the things I have to prove here. Okay. Now let me name this as equation 2. Then I will go with the cases. When f of 2a minus x is equal to plus f of x. When f of 2a minus x is equal to plus f of x, equation 2 implies integration of f of x with respect to x from 0 to 2a is equal to integration of f of x with respect to x from 0 to a and plus integration of 0 to a, sorry, integrating from 0 to a, f of 2a minus x is a plus f of x. So this is plus f of x into dx. You see what I got? 0 to a f of x into dx, 0 to a f of into dx. This is nothing but 2 times 0 to a f of x into dx. Yes, when we consider the case f of 2a minus x is equal to plus f of x, we are getting whatever is there. Next case, case number 2. When f of 2a minus x is equal to minus f of x, when f of 2a minus x is equal to minus f of x, what happens to the equation 2? Equation 2 implies integration of f of x with respect to x from 0 to a is equal to integration of f of x with respect to x from 0 to a. This is f of 2a minus x is minus f of x, minus into plus it becomes minus of f of x with respect to x from 0 to a. See, 0 to a f of x into dx, 0 to a f of x into dx. This is plus, this is minus. So, answer 0. That is, when we have f of 2a minus x is equal to minus f of x, we are getting the case as per the required. Okay. First of all, what you do, once again I am explaining, very important this one. Say 0 to a f of x into dx, that is LHS, we are integrating it from 0 to a f of x into dx plus next a to 2a. This is according to the property. Then 0 to a we want in the RHS, let it be, don't do anything. A to 2a we don't want. So, a to 2a equal to, you take it as another one integral, then you do some modification here. They have given you two cases. One is f of 2a minus x is equal to plus f of x, another one f of 2a minus x is equal to minus f of x. So, to substitute those cases, we need f of 2a minus x. For that, you substitute t is equal to 2a minus x. This implies x is equal to 2a minus t. Differentiating it, we got this, change the upper limit and lower limit. And now we are getting I is equal to 0 to a f of 2a minus x into dx. Then this integral is nothing but whatever there in the second integral in this first equation. So, substitute that in the first equation. Now, we got that second equation. You see, in the second equation we are getting whatever the function required for us, that is f of 2a minus x. F of 2a minus x we got. Now, we will consider the cases, that is when f of 2a minus x is equal to plus f of x, what happens to this? We are getting 2 times 0 to a f of x into dx. Now, second case, when f of 2a minus x is equal to minus f of x, we are getting that 0 as per the RHS part over there. Okay, thank you. Property P7 we will take it in the next class.